hopefully going to work. So, September 27th, we're going to look at section 2.2, basic derivative rules. These are all sorts of derivative shortcut rules, which means after we learn these, we're no longer really going to have to use the formal definition to calculate derivatives. These shortcut rules will get us there a lot quicker. We kind of have to see where they come from, which is the whole formal thing. But now that we're going to learn these, we're going to just use these shortcut rules. So first of all, turn this over here. My first rule is the constant rule. Make this a little bigger. The derivative of a constant equals, well, not sure yet, so we're going to see if we can figure this out. If f of x is the constant 6, what's the derivative of the function 6? Or of the function y equals 6? Why? What is y equals 6? It's a horizontal line. Right? 1, 2, 3, 4, 5, 6. What's the slope of any horizontal line? 0. Therefore, what's the derivative of any constant going to have to be? 0. Because it's like asking you, what is the slope of y equals that constant? Slope is 0. Okay. Next, we have what I'm going to call the x rule. The derivative of x is like asking you, what is the slope of the function y equals x? 1. Derivative of x, just 1. We could go through the formal thing for that. We'd get 1 for our answer. We're not going to have to use the formal thing anymore. Derivative of y equals x, 1. The power rule. And I think I'm just going to give you the rule, show you some examples, and then we'll kind of see where it comes from. But I also think I should wait just a moment. The power rule says, if I want to do the derivative of x raised to the n, x raised to some power, x squared, x cubed, x to the 10th, x to the 100th. X to the 100th would be a real pain to do with the formal definition. Here's our shortcut. This is going to equal n times x to the n minus 1. I'll show you why in a little bit. Derivative of x to the n times x to the n minus 1. So, if I have f of x equals x cubed, and I want to find my derivative, according to that formula, what number would I get out front? 3. X to the, well, subtract 1 from the power we had. 2. The derivative of x cubed is 3x squared. If I go through the formal definition and FOIL again, and subtract and simplify and take the limit, I will get 3x squared. From now on, we're just going to use this shortcut that says move the power out front and subtract 1 from the power. I would like you to go find the derivative of f of x equals x to the 5th. Find the derivative of that thing, which I feel like will involve just one line of, really, you're just writing down the answer. And I feel like this would have taken probably 5 minutes with the formal definition FOIL again, simplify, and probably mess up some of the constants, so things are going to be wrong. This is going to go a lot faster. Volunteer, what's the derivative? Josh? 5x to the 4th. Move the power out front, subtract 1 from the power.
Is that all you need to see for work?
That's all I need to see. Some of them will involve a little bit of rewriting so we can use this rule, but that's basically what I need. Why does this work? I'll show you that in a little bit. It really comes from, though, all the formal stuff we've already seen. 2 more of these. What if I have f of x equals the square root of x and want to find the derivative of that? We know very little right now about derivatives. We know how to do derivatives of constants and derivatives of things with powers. Thoughts? Raising your hand on what we could do to make sense out of this. Rigel. Rewrite it as a power. Square root just means x to the 1/2. So this one I will need to see a tiny bit of work on. I'm going to rewrite this problem as f of x equals x to the 1/2. Because now it's in a form where I can go and use this power rule. Power rule says I'm going to move my power out front, 1/2 times x to the, what happens when you subtract 1 from a half? Negative 1/2. Although I'm actually not totally done. I don't want you leaving negative powers in your answer. So a negative 1/2 is really just like a 1/2 power in the denominator. So I'm going to say 1 over 2, x to the 1/2. I would accept that. Or what else do you think I would take? 1 over 2 root x. Either of those would be okay. I'm fine with fraction powers in the answer. I'm not okay with negative powers in the answer. Jack.
We have to show the f of x equals x to the 1/2.
You don't, but I think it's going to be helpful, especially when we start dealing with a whole bunch of powers, just to keep things straight. It helps me. Things, anything.
If we do have to root x, do you want us to rationalize?
The only time you would need to is if I give you a multiple choice question saying find the derivative of this, and this 1 over 2 root x wasn't an answer, and you saw all the answers were rationalized. But in general, I am fine with 1 over 2 root x. Next. F of x equals 1 over x. I want to find the derivative of that. You know very little right now about derivatives. I will tell you there is a quotient rule for derivatives that is much more difficult than the derivative of the top over the derivative of the bottom. Can't do anything like that. Anyone have an idea how I can rewrite? I know one person does. I know a few more people. Lily. Sure. X in the bottom is the same as saying f of x equals x to the negative 1. I want to see if you can go and use the power rule now on that. Kind of the same idea as the fraction power, although maybe even a little cleaner. Move the power out front, subtract 1 from the power. That is all. Again, though, when you're done, leave no negative powers. So maybe this, negative 1 over x squared. I think, in the interest of time, I'm going to hold up on the proof of where this comes from for the end of class. I've got to make sure we get through all the calculation things first. But we will talk about where this comes from, although it really does just come from that formal definition of the derivative. I'll show you at the end. Anything so far? A little easier than what we were doing? Move the power out front, subtract 1 from the power. Next, we have the constant multiplier rule, or the constant multiple rule. Either way will work. Which says, if I want to do the derivative of a constant times a function. By the way, I've been using this symbol and haven't talked much about it. I mentioned on the first day that we call this operator notation, which just says find the derivative of the thing inside. If I want to do the derivative of a constant times some function, I can just say it's the constant times the derivative of the function. Basically, we can pull the constant out front. For example, if we have f of x, which equals 5x to the 6th, and I want the derivative of this, the constant multiplier rule, or the constant multiple rule, says I'm just going to leave that 5 out front. Times, well, what's the derivative of x to the 6th? Move the power out front, so move a 6 out front, x to the 1 less power, 5 times 6x to the 5th. Which, of course, you're not really going to tell me. You're really going to tell me 30x to the 5th. By the way, I would like you to be labeling things f, f prime. By the end, we're going to be dealing with so many different types of functions. We need to be able to know very clearly, is this the original? Is this the derivative? Our derivative here, f prime of x, is 30x to the fifth. Next, let's say f of t, why don't we change the variable, of 4t squared over 3. I want to find the derivative of that. And it might help if we first rewrite this as f of t equals, well, I've got a constant of 4/3 up front, times t squared. Go. See what you can do. Leave the constant out front, then pull down the power and subtract 1 from the power. Answer. Claire. Yep. If you feel like you need to show some work here, which no, I don't necessarily need, it's 4/3 times 2t. That becomes 8/3 t, or 8t over 3, or some version of that. Question? You look like you might have a question, Jack. Jack.
No, I didn't know I was 8t.
So, I've got that 4/3 out front times t squared. What's the derivative of t squared? We'll move the power out front.
I thought t squared on the bottom.
No, that's the next one we're going to do, actually. No, this was just 4t squared over 3, so 4/3 t squared, and then we go. I would like to see what we can do with f of x equals 1 over 2 times the cube root of x squared. Take a moment and just rewrite the original function in a way that'll make the power rule easy to use. 1 over 2 times the cube root of x squared. What's your constant out front? 1/2. Then what? X to the not 2/3. Why?
Because it's 1 over whatever that is.
Because it was in the denominator. I don't want to leave variables in my denominator. I want to kind of move them out. I'm going to write this as negative 2/3. I have not found my derivative. I just rewrote the problem. You go find the derivative of this. Bless you. As far as showing work goes, I personally find that the more work I show, the fewer little mistakes I make. But other than that, it's kind of up to you. Especially in the beginning, I would recommend, though, showing maybe a little more than you think is necessary, just so you're not making those little mistakes. When it's done, I'm going to get negative 1 over 3x to the 5/3, or I suppose negative 1 over 3 times the cube root of x to the 5th. I don't care roots or fraction powers, just no negatives. Next rule, the sum and difference rule. Which says if I want to do the derivative of f of x plus or minus g of x, all I have to do is the derivative of the first one plus, or maybe minus, the derivative of the second one. Do the derivative of the first, do the derivative of the second, add them or subtract them. And this is a big deal because it lets us deal with larger polynomials. For example, f of x equals x squared plus 3x minus 1. We're going to find the derivative of this. All we need to do is, well, each of the three pieces. What's the derivative of x squared? 2x. Move down the power, subtract 1 from the power, 2x to the first, just call it 2x. 3x, what's the derivative of 3x? 3. That's using that x rule that I gave you and the constant rule. Or I suppose you could use the power rule. This is like x to the first. Move the 1 out front. 3 times 1 to the 3 times 1 times x to the 1 minus 1 is 0. X to the 0. 3 times 1, 3. What's the derivative of minus 1?
0.
What's your derivative of that polynomial? 2x plus 3.
And you could say x minus 1 is negative 1 times x to the 0, and then the 0 that you're pulling out, that makes sense.
Will that break things down? Yeah, I guess you can. I don't know why you would, but I guess you can. Yeah, because we'll get the 0 out front. I'm not sure if that will totally work with some other things moving forward, to think about it like that. But I think, yeah, that does kind of fit into our power rule. That will work. Next. I would like to do the derivative of f of x equals x squared plus 2 times x cubed minus 4x. Have I given you guys the product rule yet? No, there is a product rule that is not as easy as the derivative of the first one times the derivative of the second. It's more involved. You guys know very little right now about derivatives. Is there any way you can handle this problem? Do that. Some of these are going to require you first to use some algebra to write it in a better form. Then it's just that sum and difference rule with power rule. Take a moment and FOIL. Oh, and then I can even combine some like terms. That's always fun. So my derivative is x to the 5th minus 2x cubed minus 8x. Good? I'm done? Got my derivative? Good? Why are you shaking your head, Sahil? We just rewrote the original. This is not the derivative. This is just algebra to rewrite the original. Now, we need to go and actually calculate the derivative, that formula that gives us slopes. Go find your derivative. Every year on a quiz, I have people who FOIL and think that's the answer. No, you just rewrote the original. Now go do your derivative rules. Volunteer to tell me a derivative of this? And volunteer with raising your hand, maybe a new person. Although I don't think I've called on Philip yet. So Philip.
5x to the 4th minus 6x squared minus 8.
Questions with this? Next one. I need to move up. What if we have f of x equals 4x to the 5th minus 2x cubed plus 3x over x squared? There is a quotient rule. That is not as easy as the derivative of the top over the derivative of the bottom. I need about a week to get to that. Again, you know very little right now about derivatives.
You could factor out its x and cancel out.
Yeah, but actually that's still going to leave me with a couple issues here. Rather than factoring, I'm just going to sort of separate my fractions so I can divide each piece by x squared, and then I can use power rule and things and not have to deal with something being left over. So, you would have been fine if all the powers up top were greater than or equal to x squared. I'm going to say 4x to the 5th over x squared minus 2x to the 3rd over x squared. This is what I mean by separating the fraction. I'm just going to divide all those pieces by x squared, which gives me f of x equals 4x cubed minus 2x plus what?
3 over x.
3 over x. How do you deal with 3 over x? Okay. What I want to write for the next line, I don't want to do like the derivative of this and the derivative of this and rewrite this thing, because then that's kind of a line that's mixing some derivatives with some original. I want every line to be either all derivatives or all original functions. So I'm going to rewrite my original in my nicer form that I can work with as 4x cubed minus 2x plus 3x to the negative 1. Now go do your derivative. But please don't, in your work, mix derivative this, rewrite the original. I want every line to be all derivatives or all originals. And again, please do label things, especially now that we're doing some algebra here. I really want to know those are still the original. Now I'm going to give a derivative. Any new volunteers? Tell me a derivative? Maybe, possibly. Ryan.
12x squared minus 2 minus 3x.
Good. Anything else I'm going to need you to do? Get rid of the negatives. So I'm going to write this as 12x squared minus 2 minus 3 over x squared will be our simplified answer. I guess we could do a common denominator thing. I'm not going to bother. That's the final answer. Good enough. How are we doing? You with me? Little nicer than the last 2 days, maybe? Possibly. Trig. Derivatives of sines and cosines. Okay, so sine and cosine rules. The derivative of the sine of x equals, not really sure. Let's see. I think this is what the graph of the sine looks like, and it continues like that. In purple, I'm doing y equals the sine of x. I'm going to try to see if I can figure out from the graph what the derivative might be. In red, I'm going to do my derivative, which means the slopes on the original get matched up with the values on the derivative. What's the slope over here? 0. My derivative should have a value of 0 there. What's the slope over here? Would it seem reasonable to say that this slope over here kind of seems like 1, maybe? Possibly, could be 1. If this is 1, what's this slope over here? Negative 1. And then this slope over here is 1. I'm drawing in my derivative right now. What's the derivative of the sine of x? What did I just draw? Cosine of x. The derivative of the sine of x is the cosine of x. So then the derivative of cosine x should probably be sine x. Let's just check that. Let's do the same thing with a picture just to make sure things are working. But that totally seems reasonable. Derivative of the cosine x equals, okay, so in purple, I'm going to do y equals the cosine of x. In red, I'll do its derivative. What's the derivative over here? Derivative over here? I guess I should probably continue that over there. 0 sounds good. Derivative here? Oh, of course, that's why no one's saying anything. Derivative here?
0.
And over here is 0. This is looking pretty good like a sine so far. Over here, what's the slope? Okay, and over here? Here's my derivative. What's the derivative of the cosine of x? Negative of the sine of x. This is not really a proof. We could do a proof with the formal definition of the derivative and using sum and difference rules from last year that we're not going to get into, but that's actually where it comes from. I think this is kind of good enough to see why the derivative of sine is cosine, why the derivative of cosine is sine. Let's do an example. we'll go f of x equals 3x cubed minus 2 sine x plus 5 cosine x. I would like you to go and find the derivative of this. First part's just power rule. The other two parts, constant rule with our new sine and cosine rules.
Oh, 9x squared minus 2 cosine x minus 5 sine x.
Good. Derivative of cosine is negative sine x. No, I don't need to see this line in the middle. We're going to get 9x squared minus 2 cosine x minus 5 sine x. Derivative of sine is cosine. Derivative of cosine is negative sine. The others, can't do yet. We'll save those for later. Anything so far here? Next. No more rules. Let's look at a couple other things. Let's try to do some tangent line problems. Tangent lines. For example, find the equation of the line tangent to f of x equals x to the 6th at x equals 1. I want to write an equation of a tangent line to f of x equals x to the 6th. I want to do this at x equals 1. What am I always going to start from if I want a tangent line? What's that like formula that hopefully you used on the quiz? That you kind of learned in Algebra 1. What does it look like, May? Yeah, can you Yep. Perfect. One of those is very easy. Not x. x1, because I told you it was 1. We need to find a y value. We need to find a slope. Where are we going to get the y value from? Plugging it into your original function. y1 is just f of 1. Okay, so what's y1? What is y1? Oh, good. Slope comes from what? The derivative. So I need to find f prime of 1, which means I think I need to go first find f prime of x. Well, f of x was x to the 6th. What's f prime of x going to be? 6x to the 5th. Go find f prime of 1, which should take you like no time at all. 6 times 1 to the 5th. It's 6. What's the tangent line? Y minus 1 equals 6 times x minus 1. Everything we did before with tangent lines still applies. But to find the slope, to find the derivative, let's just use the shortcut rules. One last piece, and I think we're going to save the proof of the power rule for next time just because I don't want to rush things, and I do want to show you one last example of this. Okay. Find where y equals x cubed minus x has a horizontal tangent. Find where that thing has a horizontal tangent.
So that would be for the derivative.
So let's think for a moment. Horizontal tangent, think for a moment about what the slope would be if a tangent line is horizontal. Don't say anything yet. What's the deal with the slope? If the tangent is horizontal.
0.
Slope is 0. Which means, for our purposes, what's another word for slope? derivative, I want the derivative to be 0. Well, let's find the derivative. What's the derivative? Of x cubed minus x. 3x squared minus 1. Should I plug something in, or should I set this equal to something? We need to set it equal to 0. It's not like find the derivative when x is 0. It's find where the derivative is 0. I'm going to set this equal to 0. I'm going to say 3x squared minus 1 equals 0. Go solve that thing. Yes? That's what I've got. Yes? I don't need it rationalized. Anyone have anything else? Don't forget when you undo a square, plus or minus the square root, so plus or minus 1 over root 3. If we looked at the graph of this and went to 1 over root 3 and 1 over negative 1 over root 3, we'd have a slope of 0 there. I think that's where I want to stop with this for today. And I'm going to not turn the power off because that will erase everything. If I push